The specific topic we are going to start is different types of control flow. Most of the times we have to deal with loops, branches, and control flow for some kind of decision makings. For some conditions, you can execute some part of the program and you may not execute some part of the program. So today we learn that how we can ask the computer to execute particular group of instructions if certain conditions satisfied. This is very important in any programming language. Once you learn some programming language, then the concept of loops, branches, and control flow, these are very important. So first we start from the control flow. Flow of control means your execution. Once you execute the program, generally your program is going to execute from top to down. Okay, so your flow, sometimes you may skip once even you are going to proceed from the top, but some part, if depends on certain conditions, you may not be, you don't want to execute, and you can jump to the some other locations. So that we learn that how we can do this. So first, very simple control flow statement available is, which is the if else. In the MATLAB you will find if, else if, and else. Okay, and switch case otherwise. So we are going to learn this control flow one by one. And simple, just like this is the, actually once you go for the programming language, then programming language facilitates the statement like the English language, so that you user can easily write the instructions for the computer. So if, else if, we also use in the natural life, real life. If this condition holds, then we will do this. If this is not happening, then we do this. The same thing we are going to do. We are going to write the instructions in the MATLAB. Okay. So if statement is simply the condition, actually you have to tell the conditions. So if logical expressions statement, logical expressions, actually these are the expressions which can evaluate true or false. So if some condition may be true or some condition may be false. So if you have some condition which is true, if a logical expression says that okay, yes, it is true, then you can execute the statements. Whatever written here, this is the body of the statement, you can execute. And if is terminated by the end, so if and end, it will come. You have to remember. So for every if you have some, you have the end. Okay. So you can see the flow chart here. Logical expressions can be true or false. So you are going to, you are at this point. Once your flow is at this point and you want to take decisions, your computer is going to evaluate this expression, and depends on this expression, you can go to this way or you can proceed to this way. If condition is false, then what you are going to do? Just you are not going to execute this block, this set of instructions, you just come to the end. So if and end, you are coming at the end. If this condition is not hold true, whatever is written between if and end, you are going to skip, and your control flow comes at the at the last of the end. So this, once you are going to execute this statement, and if this is false, you are not going to execute this, your control flow is coming to this place without executing these statements. The same thing is here. If this is true, then you are going to execute this statement. You may have any, this statement, you may have one single statement, or you can have many statements. Here you can have any complex statement. You can, here you can call function, whatever you can do. So this particular portion you are going to execute once this condition holds true. Okay, so you can see the example here. If x is some given value, you have some, x is the variable, and if you have some value in the workspace, okay, so you are checking the value for the x. So this is the condition. You are saying that this is the greater than or equal to. Okay, this we use for the greater than or equal to. So x is greater than or equal to 0. If this is true, then you are going to execute this part, this statement. So y is equal to sqrt x. You are going to compute the square root of x if x is greater than or equal to 0. If x is negative. If x is negative, then this statement will not be executed. So this is the importance of this if statement. So depends on the value of x whether you want to execute this or whether you don't want to execute this. So this simply says this. SQRT is the built-in function in the MATLAB, compute the square root. Okay. Here logical expressions simply they can give the value true or false. True means you can mean true means 1 and false you can say false means 0. So once you have 0, it means once this expression outputs 0, then this is the condition false. If it is not 0, then it is true. So non-zero value may be negative also or maybe positive also. If there is a non-zero value is here, then this condition is going to true. And if this is false, if and only is you have 0 here. So when you have the non-zero value, this condition is true, and when it has the 0, it is false. So you can also say that if 1, because this is true actually, so it always true. Okay, so this is the logical expression means they can be evaluate numerical value or true or false boolean, just like boolean. So if you have the numerical value, so 0 denotes false and non-zero value denotes true condition. Some complex structure you can see. If you can have the nested if statement, just like we have seen nested function. Nested means within the one if you can have another if. So just like this is the if and this is the end of this, and within this if and end you have other if and end. So this is the nested, you are going to nest. So when if and comes inside the if and other if and, then this is the case of nested. And philosophy remains same. If logical expression 1 is true, then you are going to execute the group 1. Okay, and if logical expression 1 is not true, then you are not going to execute this, you are just testing this condition. So you are testing that if logical expression 2, if this is true, then you are going to execute this, and if this is false, then your control flow comes at this point and you are at this point. If else, here we have seen that okay, if logical expression is true, then you can execute the statement of group 1. Otherwise, if this is false, then this is the other options. So this is just. Now you can have multiple choices, and for the multiple choices you can go for the ELSEIF again. So like this. So here you have the multiple choices. If logical expression 1, statement group 1, if logical expression 2, statement group 2, else statement group 3. Now can anybody tell me when statement group 3 will be executed? So see, if logical expression 1, if this is true, for example, if this is true, then your computer is going to execute this statement group 1. Whatever you have written here, all statements will be executed if logical expression 1 becomes true. After that, your control flow is at the end. You are not going to execute other things. Are you getting this? So when this logical expression 1 is true, you are going to execute this, and your control flow after execution of group 1, your control flow is at the end. But if this is false, instead of true, if this is false, if logical expression 1 is false, then you are not going to execute the group 1. You are false, then you are going to this part, else if part. Again you are checking logical expression 2. If this is true, then you are going to execute this part, group 2. And after execution of group 2, your control flow will be at the end. You are not going to execute this. But if the logical expression 2 is false, okay, then if this is false, then what you do? You have to go for the else part. So you are going to execute group 3 if and only if expression 1, logical expression 1 is false, logical expression 2 is false. Then you are going to execute group 3. In this way, you can have any else if. You can have multiple else if. You can else if, again you have the else if, means any number of times you can have the else if. There is no problem. So if you have the multiple choices, if this is true then this, then if this is true then this, if this is true then this, if none of these are true, then you are going to execute some particular group. So this is the else if is used like this. This is the execution of that. So this is the if part. Then if part, if logical expression is true, then you are going to execute group 1 and end. If this is false, then you are checking this second options, logical expression 2. If this is again false, then you are executing the else part. This is the else part. Okay, so this is else part. And if this is true, then you are going to execute group 2. That's all. So at any time, only you are able to execute only one group of statements, either group statement 1 or group 2 or group 3. Just like the mutually exclusive. So at one point, depends on the condition, you will be able to execute only one group of statements out of these. Now this is the example you have. So if x is greater than 0, y is equal to log x. Log is the built-in function, compute the logarithm of x. So if x is greater than 10, you are computing the log x. Else if x is greater than or equal to 0, in the first case, you have the greater than, and second you have the greater than or equal to 0, means you are also including 0 here. Then you are computing the square root. Otherwise, what happen? If x is not greater than 10 and x is not greater than or equal to 0, then you are going to execute the else part. Y is equal to exponent, and you are going to compute the exponent of x minus 1 and end. So this is the statement. What is the order in which the things are going to be checked if condition? Are you starting from the else if or if? So generally we have to start from this point. Okay, first this condition is checked. If x is greater than 0, if this is whole true, then you are going to execute this, and then you are out of the body. So you are at here. So if this is x is greater than 10, then you are going to execute this. If this is false, then you will execute, you are going to test this. If this holds true, if x is greater than 0, or you may have the less than 10 also, including 0, then you are going to execute this part. X, you are going to compute this. So if this is false, then you are checking this. If this is true, then you are going to execute this. And if this is false, then you are going to execute this. So now this is one example you can see. Here I is equal to 9, j is equal to 8. And this is actually equal to sign. Okay. This is used for the equal to sign. Means you are this is not the assignment. This is for the assignment. Okay. You are assigning the value 8 to variable j. 9 is assigned to I. Here you are going to compare I and j. So this is the comparison. This is used for the comparison. If I is equal to j, if this is true, if I and j are same, then it will return the 1, means true. If this is true, then you are going to display this message. Both are equal, means equal. Else if, now remember here, else and if. This is not else if. Else is other. Else, within the else you have the if condition. So this is actually. So you have if else. Actually, you just have the if and else. And within the else, you are going to check. You have the from here to here. You have the group of statement. You can say. So if this is true, if I is equal to j, then you can just execute this. Otherwise, you are going to execute. You are going to enter into this part, and depends on the situation. I less than j, you are going to display this message. If I is less than j, you can display I is less than j. Otherwise, you can display I is greater than j. So I is not equal to j. This is false. I less than j is also false. Then only one option remains. I is greater than j. So you are going to say. Now remember that whenever you have the if, you must have the matching and. So for this if, you have the and. And for this if, you have the and. So if else, within the else, you have the if condition. Okay. So this if must be terminated by the and. So this is just like the one group you have. And if you see the right side here, here you have used the else if. Once you go for the else if, then for this else if you don't require and. So this and is just for the this. This is just for this. If I is equal to j, display equal. Else if I less than j, display I is less than j. Else display I is greater than j. So here else if is just is it is not the else and if. So that's why you don't have the and for this else if. Only you have the and for if conditions. Remember. So output will be, you know that out in this situation, you have the output I is greater than j, where this part is executed. Here also I is greater than j. When I and j are vectors, then in case of the vector, if you have the a is equal to something like this, 1 0 1 5, maybe like this. If this is the vector, then actually in this case, what happened? When a is vector, then it is going to check every element for the non-zero. If every element is non-zero, then it is actually it is going to say true. It is true. But if at least one zero observed, then this becomes false. So in the case of the vector, then all if for condition being true, every element of the vector must be non-zero. If any one elements become zero, then it will become false. So if you have the a is equal to say for example a is equal to rent this है ना, ये आपका 3 by 3 मैट्रिक्स. Are you getting? If a if a display, say for example display something um, and if has, then you have to matching and this. See the situation. Answer high. If a is the vector, then since every values are non-zero, then condition becomes true. If you modify, say a is this, if you say a 2 by, which elements you are going to target? Say you are assigning 0. Now you can display a. This is a. Now one elements you made 0, and you can say now again you can execute the statements. If a, okay, then display high. You can say else part also, else. Okay. False. Maybe like this, and then you can have the main. and. So the answer is false. B is equal to yeah, मान लीजिए कि see what happens. If A is equal to B, then you say display hello, else display hi. Okay. And you can say and. You can give the same value also. So if you have the A, say for example A is equal to 2, 3, and you can have the 4, 5. Okay. Then you have the B. B is equal to A also. Sorry. So you can have B is equal to A. So B, A and B become same. 2, 3, 4, 5. Now you can see display. If A is equal to B, then you can say display high. If elements are same,
Yeah.
B and A become same. A and B are same. That's why it is going to execute if this condition becomes true. So equal
Yes,
to
yes.
actually A and equal to B. Equal to means you are checking equal to sign actually.
Yes, yes.
So vector should also be the same dimension as well as element.
Yes.
Actually, generally, once you have the expression, it evaluates. Okay, and during the evaluation, you may have the parenthesis, you may have the plus, minus, division, right? So once you must take care that whenever you are going to evaluate something, then you have to see the precedence of the operator. So first parenthesis, within the parenthesis you have to solve. Then transpose, then power. This is the second level. Third level, unary plus, minus, logical negation, not. In the fourth level, multiplication, division, is of left right subdivisions, matrix multiplications, like this. Division and multiplications. And then you will have the addition, subtraction are in the same level. Then you have the colon operator, then less than or equal to, element wise and element wise are, short circuit and short circuit or. This say if A is equal to 10, B is equal to 6, and if you say A and B, this is actually logical and you are going to do logical and. Okay, but this is also doing the logical and in short circuit. This is both in short circuit. So why it is the short circuit? In this case, actually, the first, whatever this is the operand, first operand, it is going to check. Say, for example, if A is equal to 10, if A is equal to 10, then can you make decision until you check B? If A and B both are true, then actually it will become true. You can do single operand. This is also AND, A and B. But here actually difference in this and this is what? Here you have double ampersand sign means this denotes the short circuit. Short circuit. Why it is used short circuit? Because A and B, the first operand is actually going to check. So first operand value is what? A is equal to 10. 10 means non-zero value, and non-zero value means true. This will become true. Can you make decision on the basis of this only? Until you check this, you cannot say anything about this statement. Yes or no? So if A is true, then you have to check for the B. If B is also true, then you can say that, okay, yes, this is true. Whole thing is true. But if say, instead of A is equal to 10, if A is equal to 0, Then once a becomes 0, then 0 means false. 0 and b means, I can say, 1. This is 1. 0 means false. Say age, this is a is equal to and this is b is equal to. If a and b, this is a logical end, but this denotes the short circuit. Why this is short circuit? Because if first operand you are going to check, and if this become false, then you are going to identify that the whole statement will become false. This you don't require to check b for the b. Means you are not going to evaluate this expression. Actually, what we are talking about, you have the AND and you have the double AND. Both are actually used for the logical AND. But whenever you have this double, this is the double ampersand you have, like A and B. This means once expression A is false, if this is false, then we know that the whole statement will become false because it is connected by the AND. So you don't require to evaluate this expression, are they true or false. Whatever be the value, true or false, okay, your decision is not going to change. So you are going to execute the expression, evaluate the expression B if and only if A is true. Similarly, you have the OR. So you have, this is also used for the short circuit. So if A or B, this is OR, this or this. So if A becomes true, if you know that if you are going to evaluate this expression and if this expression is true, then you don't require to evaluate this expression because you know that if one of these two operand is true, then you can say that whole one is true. So they are actually used for the short circuit. In case of A or B, you can say A or B, and in this case both operands are being evaluated, and if any one of these are true, then the expression value will be true. So this is the difference. This is the big picture. So you can have any number of time else if. Within the if, you can have any number of time else if. So multiple time. If logical expression 1, then you are going to execute group 1. If this is false, then you are checking for this. If this is also false, then you can check for this. If this is also false, then you check for this. And if this is also false, you check for other else if you have. Otherwise, if every expressions are false, every logical expressions are false, then you are going to execute this part. So at a time you are able to only execute one group. So either you can go for the else part, else if and only if all such values are false, 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 and false, then you are going to execute this. So instead of else if, one more strong structure is there, that is the switch. So for getting rid from the else if, you can also use the switch case statement. So just every time you don't require to write the expression value 1, value 2, value 3 like this. So here switch and end, every switch has matching end. So this is the switch and this is the end. This switch between this and this. So now only one group will be executed in this case also. The control flow will be from top to bottom. Okay. This is the optional, otherwise is optional you have. So you can see switch variable or expression. Variable just like you can say A. In your workspace, A can be constant string, A can be string also, or A can be scalar. So this is the name of the variable, expression containing the value of the switch parameters. Now here you have expression. The expression can be within the switch. This is one important thing you have to note, that the expression must evaluate some numeric value or it can have some string constant. So here vector नहीं चलेगा. Here you should not have the vector. Are you getting? So you should have the numeric value, or you can have some string constant. Like you can say a is equal to hello. A is equal to hello, and here you can have, if a is hello, then variable a switch a, and now you can have different. Here you have the strings. You may have the hello, or you may have the hi. So if hello is there, you can go for this. If hi is there, a is equal to hello, then you can go for this. A is equal to hi, then you can go for this. Otherwise you can go for this. And if you have the expression, then this must evaluate the numeric value. It is not the vector. So switch case is very simple as compared with the ELSEIF. This looks good also. So you just write, this is the switch, this is the keyword, you can say fixed. You have to write the switch. Then after switch, you have to write the expression that evaluates numeric, or you can have some variable that has the numeric value, or it can be string constant. Now depends on the variable or expression value. You are specifying the options here. If value is this, then you can do this task. If value is this, then you can do this task. If value is not this and value is not this, then you are going to execute the other part otherwise. So if variable or expression value is not this or not this, then you are going to execute this. So at a time you are only able to execute one group, not more than one group. Here also. And again, executed from the top to bottom. So are you getting? You may omit this if you don't want other cases. If one is value 1, for value 1 you can do this thing, for value 2 you can do this thing, and you don't want to do anything if values are different. So this is optional. This is otherwise is optional. If you want to write that, okay, if value is 1 then this, value 2 then this, and if it is not the case, then you can go for the otherwise. So otherwise is optional, and it is very simple. You have to switch. You are writing switch. Remember that s is small here. Okay, s always write small. Switch. Then you have the, after switch you have to mention the variable. Then you can say cases. Case. You have to mention the cases, and every switch has some matching end. Like this. You can see. Okay. So say that switch input, assuming that input number, you have some input in workspace. This is the variable. You have some values. In input number, you have some values. Okay. So you can have any values. Maybe 0, maybe 1, -1, whatever you have the value. Any value it can have. But what you want actually, you want to see that if input num, means if the value of this variable is -1, the switch, this is the variable, switch variable, and this gives some numeric value, and you are going to test here. Case -1 means if variable value is -1, then you are going to execute this. Input, this is the variable name, input string. You are going to assign -1. You say that -1. If case 0, if the value of this is 0, then you assign this input string to 0. If case 1, then you are saying that +1. Case, here one thing is you need to know that if you want to say that more than one values, if you want to specify, then you have to put within the process. This is within the. So like this, if case -10, you can say any number out. Here you have the -10, then 10, you can say 5, 6, like this. You can have any number of values. So if input num has value -10, or input num has value 10, or input num has value 5, or input num has value 6, then you want to do this particular thing. So if you have more than one value you want, then you can put in the block, and curly braces are used for the block. So you want to say that if input number means this variable value is -10 or 10, then you are going to assign +-10 in the input string. If input number variable is not -1, not 0, not 1, also not -10 or not +10, then you are going to execute this other values. Say one simple problem you have. Build a program which which receives a variable x and its unit. We have the variable x. We have the variable x and its unit can be in the mm, cm, inch, means millimeter, centimeter, inch, meter, like this. So x is a variable which receives unit. So this is what you can, x is the string variable actually, and calculates y, its value in centimeter units. So according to the unit, you are going, whatever you are going to enter. Say for example, if somebody says that 10 mm, 10 mm, okay. If you have the 10 mm, unit is x denotes the unit. If x is unit, variable x, and so you have to receive a variable x and its unit. So variable x has value 10, and unit can be the strings, and unit can have the mm, cm, inch. If unit is millimeter, then what is your answer? Your value should be centimeter. So you have the 1 centimeter. So whatever is the input, you are going to convert into the centimeter. Input can be in the millimeter, input can be centimeter, input can be inch, input can be meter. And we have to use the switch case. And this is the formula for converting the inch to the centimeter. 1 inch is equal to 2.54 centimeter. If somebody enters the inch, then you can convert into the centimeter. Then write a comment for the errors case. Save the file under units.m. Okay. Now see, this is the solution. You know the x is the variable. X is variable. So x can hold some value, and then we have the unit. So x is the variable which is going to have the values. Then we have the unit. Unit is the string, and unit can be anything. Here is the mm. You can have inch, you can have meter, whatever. So actually, sometimes users can enter the unit, sometimes mm, sometimes centimeter. But so what you want, that whatever is the unit, you are going to convert into the centimeter. So you are going to use the switch case. Switch unit. Unit is the string constant. This is the string. So string variable, and it gives you have the strings. So case. Now in means some unit. Somebody may enter the units as in, somebody may say that inch, full name inch. So if either in or inch, if string can be equal to in, or string can be equal to inch. So this is the block. If these are both, for both the cases, you have to do this. So y is equal to 2.54. If inch is there, then you know that 1 inch is equal to 2.54 centimeter. So you are going to convert. That's why y is equal to, y holds the value in the centimeter. So y is equal to 2.54 multiplied by x whatever be the value. Now if case am or meter, somebody may enter somebody may say that okay, meter. So in case am or meter, you have group in the block, means either am or meter. No worry. What you are going to do, whatever is the value of x, if it is the meter, just x is equal to, say for example, 1, then you have to multiply by 100. So you have the 100 centimeter. So this is case. Third, somebody may enter mm, means millimeter, or somebody may say that millimeter in the string unit. So in these, either of the case, either millimeter or string can be millimeter, or somebody may enter short name mm. Then also whatever be the millimeter, you have the millimeter, and you are going to divide by 10. So if somebody enters the 10 millimeter, means you are going to divide by 10, means this is the 1 centimeter. So value in the 1 centimeter display. So here you have the display num to string. This is some specific format on the num to number to string x. This is the part you can use for the decoration. Question in the case cm or centimeter, then y is equal to x, because you want to convert into the centimeter. Otherwise, you can display the message unknown units like this, unknown units. So units has, whatever the units has value, this is the unknown, and not a number like this. So this kind. So otherwise part you can display. Whatever you can enter for the value x, you are going to convert into the centimeter. For converting the centimeter, you have used the switch case statement. So switch, for this switch you have this AND, only one AND.